Good morning, class. You are welcome to another series of practical biochemistry, general biochemistry 1 with course code is 201. We have started as practicals in general biochemistry. The last time we had contacts, we treated the dissociation constant of weak acid. Today we shall be taking a look at the reactions of carbohydrates. And under reactions of carbohydrates, we shall be looking at the Demolish Test, Benedict Test, and these two tests shall be applied on the some carbohydrate that will prepare for us. And, in order to have a deep knowledge of the topic, it has also been taken in the theory class. I will invite Mr. Moses, the lecturer in the Department of Biochemistry, to come and take us on the principle. Mr. Moses.
Thank you very much. Good morning once again, class. I'm Mr. Moses. I believe we have kind of met in our theory class. I covered the aspect of carbohydrates, and I believe by now all of us were conversant with carbohydrates. So, by means of refreshing our memory, let's go through the summary of carbohydrates. We discussed that carbohydrates are polyhydroxy aldehyde of polyhydroxy acetone. They are polyhydroxy aldehyde of polyhydroxy ketones. They are important macromolecules in nature. So we said in our theory class, the general formula for carbohydrates is CnH20N. So that's the general formula, or we can call it the empirical formula of carbohydrate. So from here we know that generally we can say that carbohydrates are hydrated carbons. So today we are not going to digress from what we have been talking about. We are going to take some tests as was introduced by my senior colleague. We are going to take some tests. The first one, the Demolish Test, then the Benedict Test, and then the final one we are going to test for Sucrose. So the first one we are going to take is the Demolish Test. So the Demolish Test is used to identify carbohydrates. It's a general test that is used to identify carbohydrates. The principle of this test is basically the reaction between a strong acid either H2SO4, H2SO4 or HCl, that's hydrochloric acid or HCl. So it's basically the reaction between between a strong acid and carbohydrate, which can either be monosaccharide, disaccharide, oligosaccharide, or polysaccharide. And not only carbohydrates, not only carbohydrate macromolecules test positive to this test. Nucleic acid and nucleic acid also test positive to this test, because we know nucleic acid contains pentose, and pentose sugar is a vital or that's an important part of the DNA. So we said the principle is basically the reaction between strong acid and the carbohydrate, which dehydrates it. So pentoses are dehydrated to furfuras, while hexoses are dehydrated. To 5-hexomethyl furfural. So these furfural will then react with two molecules of alpha naphthol, which will form a purple ring. So it's basically the reaction between these furfural, these dehydrated sugars, and naphthol to form a purple ring. So this is how Demolish Test is being done. So they are going to all these carbohydrates will be provided, and we are going to check and carry out the test for each of the Demolish test on each of the carbohydrates. So that's all about the Demolish test. So the second test we are going to carry out is Benedict test. So from our lectures, from the theory part, we discussed Benedict test, and we say it's test for reducing sugar. That's another name for Benedict test. That's test for reducing sugar. So the Benedict test is just used to identify reducing sugar, which are monosaccharides, monosaccharides, and some disaccharides. So, these are the sugars that can test positive to Benedict solution, to Benedict test. So they do that because they have free aldehyde group and free ketone group. So all aldehydes, all monosaccharides, that is aldoses, all aldoses, they test positive to Benedict test. But ketones, that's the ketosis, they don't normally test positive to Benedict test until they undergo a reaction in a basic solution. They undergo a reaction which is called Enedol reaction. So they undergo a reaction called the Enedol reaction, which converts those ketosis to aldoses. It converts ketosis to aldoses so that they can test positive to Benedict test. So the Benedict reagent is just an alkaline solution of copper. It's an alkaline solution of copper sulfate, and as I've mentioned before, they react with the free ketone group or aldehyde group of the monosaccharide to change color. So the normal color of the copper sulfate is blue, which is the normal color. So it changes color to reddish brown. That is after the reaction is complete. So I made mention that disaccharides, only few disaccharides can be able to can test positive to this reaction. One of the few ones is maltose, which we are going to see in our practical today. Maltose is, as I've already mentioned again in the theoretical aspect, maltose is a D-glucose that is joined together with another D-glucose. The first D-glucose is either alpha D-glucose, while the second one can either be alpha or beta D-glucose, and they are joined together via alpha 1,4-glycosidic linkages. So the reason why these maltoses show positive results with the Benedict solution is because they have free anomeric carbon. If you remember from our theoretical aspect, we made mention of anomeric carbons. So the anomeric carbon in the second glucose is not used. It's not used for the ethyl linkage, which is the glycosidic linkage. So that's the reason why it tests positive for Benedict test. And another disaccharide, which is sucrose, it doesn't test positive to Benedict test because all the anomeric carbon they are used for bonding. If you remember again, the glycosidic linkage between the anomeric carbon 1 of glucose and anomeric carbon 2 of fructose. So that's why it does not reduce Benedict solution. So this is basically the principle. All right. So we've already seen how disaccharide and monosaccharides react to Benedict solution. So the next one we'll look at is polysaccharides. Polysaccharides react negatively to, they give negative results with Benedict solution because all the anomeric carbon they are used in bonding. We know that polysaccharide is a polymer of glucose. They are joined in alpha 1,4 glycosidic linkage. So and we know that starch there are different types of polysaccharide. One of them is starch, which we exhaustively talked about in our class. So I will say starch contains of amylose and amylopectin. So they are basically a polymer of glucose. And all these glucoses, the anomeric carbon they are used for bonding. The same reason we made mention that sucrose does not reduce Benedict solution is the same reason that's applied on starch. So starch, all the anomeric carbon in starch are used for bonding purposes. So that's why it does not reduce Benedict solution. So the last test we are going to take is sucrose. If you are following, we made mention of sucrose that it tests negative to Benedict test. So a way to mitigate that, or the way to carry out or identify a sucrose solution is, first of all, it has to we have to subject it to hydrolysis, which is either acid hydrolysis, alkaline hydrolysis, in order to break the bond between the glucose unit and the fructose unit, which is the alpha 1 2 beta glycosidic linkage, so that it will free the anomeric carbon. So after hydrolysis, we will carry out Benedict test, which we already mentioned, we will explain in detail. We will carry out Benedict test so that we will confirm that this hydrolysis is successful, and also it will lead to color change, which will help us identify that we will identify the presence of carbohydrates. So these are the tests. These are all the tests we are going to carry out: the Demolish test, the Benedict test, and also the test for sucrose. So I'm going to invite the chief laboratories in the department to come and demonstrate all the practicals for us. Thank you very much.
Okay, Mr. Moses, for that brief introduction of the theory. Now we shall be going to the practical, and then we'll be taking out the tests you highlighted one by one. The first one we shall be starting with is the Demolish test. And now we move from the board now to the practical demonstration table. Here, I have already prepared starch solution, sucrose solutions, maltose, and then glucose solution. And I have some cleaner test tube with me here that we use to carry out the reaction. For the demolish test, what you will do is to take 2 ml of each of these test solution. Ideally, we supply the name of the carbohydrate provided because we really want to demonstrate how each carbohydrate reacts to this reagent, so that in future, when you come across it, you'll be able to know that this is the exact reaction for each of the carbohydrates. So, like it has been stated by the lecturer that took the theory class, that Molly test is a general test for any carbohydrate containing compound, not only for carbohydrate, any compound that contains a carbohydrate molecule will test positive to Molly test. So we refer to it as a general test for carbohydrate. So how do you perform the test? I'm having 4 carbohydrates here. So I've selected the 4 clean test tube on my test tube rack. Into each of the test tube, I will take 2 ml of each of these carbohydrates into each of the test tube. Thereafter, 2 drops of alpha naphthol solution will be added to it, while 2 ml of conc sulfuric acid, H2SO4, with IUPAC name of tetraoxosulfuric acid, will be added to it. But why added the conc H2SO4? You have to hold the test tube in a slanting position so that the furfura that will be formed will not mix up with the entire solution. So as I was saying, after adding 2 ml of the test solution to the test tube, you add 2 drops of alpha naphthol into it. You mix thoroughly by shaking the tubes, and after that, you now add carefully. You add 2 ml of a conc H2SO4. You let the conc H2SO4 to run down the wall of the test tube. Immediately the conc H2SO4 gets in contact with the mixture, the action will take place. That is, the dehydration of the carbohydrates, if it is pentose, to furfura will be formed. As a matter of fact, a ring coloration will be seen separating 2 layers. The color of the ring now depends on the type of carbohydrate, whether it's a monosaccharide, disaccharide, or polysaccharide. But the more monomeric units in that carbohydrate, the more intense the color of the ring will be pronounced. So basically, that's how to test for compound containing carbohydrate. The most feasible reaction is that immediately the conc H2SO4 gets in contact with the test solution, formation of furfura will be formed, and then you will see a ring layer or a brownish ring separating 2 layers, one at the top, one at the bottom. When such reaction occurs, it shows that that compound is containing carbohydrates. So to demonstrate the reaction for each of these carbohydrates, 2 ml of each of these carbohydrates provided, starch, sucrose, maltose, and glucose have been measured into the test tube. I will now add 2 drops of alpha naphthol solution into it. While adding the 2 drops of alpha naphthol solution into it, you make sure that you dip the partial pipette into the test tube so that the drops will go straight into the solution. 1, 2. You mix. alpha naphtol has been added to the starch. The next solution is sucrose. I will add 2 drops to it. The next one is maltose, already labeled, 2 drops, and the last one is glucose. Then you mix properly by shaking the test tube. After that has been done successfully, the next thing for you is to add concave 2SO4. While adding the concave 2SO4, make sure you hold the test tube with a test tube holder and hold it in a slanting position like this. Then you just add a few ml of concave 2SO4 into it. You can see the reaction. For sucrose, you can see at the bottom the formation. The upper layer is clear one, while there was a ring, dark brown ring formation that separated 2 layers here. So that's confirming carbohydrates. The next one is maltose. If you look carefully at the bottom of this test tube, you will see a layer. Then at the top, you will see another layer. While you see a brown, darkish brown ring also separating the layers. So that's to tell us that the compound is a carbohydrate or contains carbohydrate molecule. You can also see this is the last one for glucose. You can see the upper layer, and you can see the bottom of the test tube with another layer, and a darkish brown ring also separating the 2 layers. So, and the essence of slanting your test tube while carrying out this reaction is to make it so that the ring or the layers will be visible. If you stand it, it will mix up. Like now, you can see the one I performed. The ring layer will go down and to be deposited at the bottom of the test tube. But here, by slanting it, it is very clear and visible. You can see the uppermost layer here, and a very clear solution at the bottom, separated by a black or darkish brownish ring at the bottom. So this is how to test for carbohydrates using a Demolish reaction. The next reaction we have to carry out is Benedict Test or Benedict reaction. Benedict reaction will be applied on the four carbohydrates, the starch, sucrose, maltose, and the glucose that we have here. How do you perform a Benedict reaction? 5 drops of each of the carbohydrates will be put in a separate test tube. That is, I will have 5 drops of starch in a test tube, 5 drops of sucrose, 5 drops of maltose, and 5 drops of glucose already labeled. And after that, 1 ml of Benedict reagent will now be pipetted and added to each of the test solution. Take each of the test tube out of the rack and mix properly. After mixing the Benedict reagent with the test solution, the next thing is to take the tubes or the mixture to a boiling water, that is water bath, and heat for 2 to 3 minutes. You heat for 2 to 3 minutes. So I'm moving to the location of the water bath, the ferment. So I will have to heat. You dip the test tube inside the boiling water and make sure you heat up for 2 to 3 minutes while in the boiling water. We have a minute more. So we draw our test solution from the boiling water and observe the reaction. Now, let's place them in the rack and begin to examine the reactions that are taking place one after the other. Now, as you can see from the rack I'm holding, tube 1 here is for starch. You can see the color. The color did not change. The copper still maintains its bluish color inside the solution. That's why it's being heated. While the second one is sucrose. As you can see, the color still retained. And the next one is maltose, changing from a bluish color to orange color, deep orange color. And the next one is glucose, changes color from bluish coloration to deep orange color. That confirms to us that maltose is a reducing sugar. Likewise, glucose is a reducing sugar. White starch and sucrose are not reducing sugar. So you can confirm from this reaction that two of the carbohydrates given to us test positive to Benedict test by changing the color from a bluish coloration to deep orange coloration. And that is maltose and glucose, confirming to us that they are reducing sugar. White starch and sucrose did not change from blue coloration to deep coloration, indicating that starch and sucrose are not reducing sugar. The reaction, as we have it here, the first test tube, like when I showed you the other time, is for starch. This is for sucrose. This is for maltose, and this is reaction for glucose. So you have to record your procedure in a tabular form like this under test, observation, and inference. The test you carry out, you put it here. The test is for starch, 5 drops of starch solution plus 1 ml of Benedict reagent. 5 drops of starch solution plus 1 ml of Benedict reagent. This is what it gives us. In this test tube, I have 5 drops of starch solution, 1 ml of Benedict reagent, then plus 3 minutes of heating. And at the end of the day, this is what we have. So at the end of the day, when you prepare your test and carry out the procedure, 5 drops of starch solution in the test tube, plus 1 ml of Benedict reagent, and plus 3 minutes of heating, you have this. So the color before heating is blue, bluish coloration. After heating, now this is what we have. So you observe whatever thing you observe there, you put it under your observation. Then the observation will give you the inference. Like, for purpose of clarification, let me do this first row for you. The first row is for the reaction of starch. After adding 5 drops of starch with 1 ml of Benedict reagent and 3 minutes of heating, it was observed that the color remained the same. The color did not change. You put it there that the color before heating was bluish coloration, which remained the same after heating for 3 minutes. That is our observation about the reaction. Then from this observation, the observation will surely lead us to a particular inference. And the inference to this particular one is that starch is not a reducing sugar. Starch is not a reducing sugar. Starch is not a reducing agent, or it's not a reducing carbohydrate. When you use sugar, sugar is a general name for carbohydrates. Or you can simply say starch is not it's not reducing, or it's not a reducing agent. It's not a reducing agent. it's not reducing carbohydrates. Is that taken? So the same thing applied to sucrose. The test you carry out on sucrose, 5 drops of sucrose solution was taken into the test tube, 1 ml of Benedict reagent was added, then with 3 minutes of heating. What happened thereafter is what you observe in this test tube that I'm holding. So put your observation here under this column, then let us have your inference. For maltose, of course, you know that your maltose is a disaccharide comprising of 2 D-glucose units. 5 drops of maltose was taken into the test tube plus 1 ml of Benedict reagent with 3 minutes of eating. What happened? After 3 minutes of eating, initially the color was bluish and it changes to, so whatever thing that happened under this practical demonstration, put it under the observation column, then you let us know the inference. For glucose, 5 drops of glucose solution plus 1 ml of Benedict reagent with 3 minutes of eating. Give us this reaction from initial coloration of bluish color to the color I'm holding here now. So put your observation here as I did for the start solution. Put your observation for glucose under the observation column and give your inference. Start carrying out the Benedict reaction on the 4 carbohydrates that we have available, and we have seen the resultant effects, those that test positive to Benedict and those that test negative. That is the one that have reducing property and the one that doesn't have the reducing property. Now, we want to look at the sensitivity of glucose solution. Sensitivity of different glucose solution to Benedict reaction. What we will do is to prepare increased concentration of the different dilution of the glucose solution and the test for the Benedict reaction and see what will happen. So here it has been prepared here. I have 1 ml of glucose solution prepared to this 5 test tube. From test tube 1 to test tube 5, and each of the test tube have been diluted with distilled water. Into test tube 1, I have 1 ml of our original glucose solution with no water added. Test tube 2, I have 1 ml of our original glucose solution with 1 ml of water, distilled water added to it. While test tube 3 contains 1 ml of the glucose solution with 2 ml of distilled water. Test tube 4 contains 1 ml of the glucose solution with 3 ml of distilled water. While test tube 5 contains 1 ml of glucose solution with 4 ml of distilled water. And you shake and mix up the solution properly. After that, I will now add 1 ml of Benedict reagent into each of the 5 test tubes. Boil for 2 to 3 minutes. Then I will observe what will happen. forget we have to add 1 ml of the Benedict reagents to each of the test solution now in a diluted form. So then need to you mix properly and take it to the boiling water. You have to label so that you don't mix up this is tube 1. Already we are eating the 3-5 test tube containing different dilution of glucose. You also have 18 seconds more. Let's go back to the demonstrator table. Now, as we can see from test tube 1 to test tube 5, this is test tube 1 containing no water. You can see the color of the reaction after eating for 3 minutes. The orange color is highly intense and deep. The next one containing 1 ml of water. You can see the trend of the color now. It's fading out compared to test tube 1. Test tube 3 now containing 2 ml of water. It's almost losing out on the orange color. Then white test tube 4 having faint orange color. Test tube 5 containing 4 ml of water is slightly orange color. The intensity of the color from test tube 1 to test tube 5 continue to decrease proportionally to the quantity of distilled water added to it. So that's how to test for the increasing sensitivity of Benedict reagents to different concentration or dilution of the test solution. Thank you. The next reaction we shall be taking a quick look at is a test for sucrose. We have already carried out Benedict test for sucrose in the first reaction, but we want to carry out further reaction on sucrose. The first, we will carry out acid hydrolysis on it. Don't forget the other time Mr. Moses was telling you that sucrose contains of 2 monomeric units of sugar, glucose and fructose. The bond, without breaking the hydrolytic or glycosidic bond that attach these 2 monomers together, Benedict reagent cannot test positive to it. So we will apply acid hydrolysis on the sucrose, alkaline hydrolysis, and also we will heat in the boiling water for 2 to 3 minutes to see whether the acid used has been able to break the glycosidic bond or not. If it does happen, by applying Benedict reagents on it and heat up for 2 to 3 minutes, there's possibility of the hydrolysis of the glycosidic linkage to have taken place, whereby you will now see the glucose monomer in it. We reacting positively. So the reaction may not be prominent like that of reducing sugar, but you will see sign of changes of color from bluish to maybe dirtish brown or greenish something to really tell us that there is a mixture of color in it. That's the next thing we'll quickly carry out now. Sucrose has been added to this test tube. That's our test solution. With 5 drops of corn hydrochloric acid added to it, and after that it was boiled for 5 minutes, or it was heated up for 5 minutes. Is that taken? The purpose of carrying out this two procedure is that the conch HCl will be able to carry out acid hydrolysis of the glycosidic bond between the glucose and the fructose. While the heat also, peradventure the conch HCl will not be able to do that. The process of heating, which we know as a thermal, will carry out thermal hydrolysis on it, and subsequently it is expected that the bond will have been broken. So, after taking out from the boiling water, you are allowed to cool. Once the mixture is cool off, you will now need to add dilute sodium hydroxide solution into it. By the time you begin to add sodium hydroxide into it, to make sure that you have a neutral solution, you continue this addition of sodium hydroxide, but you have to observe the reaction very well. By the time sodium hydroxide is getting into the solution, effervescence will start to occur. You see bubbles moving up, and you continue to add until the effervescence stops. So the next thing now on the preparation inside this test tube is to carry out Benedict's reaction on it to really know whether the mixture will test positive to Benedict reagent or not. So what do? We will take 1 ml of this solution into another clean test tube. Add 1 ml of Benedict reagent to it, and then boil for 2 to 3 minutes in the boiling water. So I have my 1 ml of the hydrolysis in the test tube, and I will now add 1 ml of Benedict reagent to it. And I will need to heat up for the period of 2 to 3 minutes in our water bath. So I'm moving to the I have to time it 2 to 3 minutes. So about 3 minutes, after 3 minutes, after boiling the heating up the hydrolysis for 2 to 3 minutes, this is what we have from the sucrose solution here. As you can see, when we test directly for sucrose solution using Benedict reagent, it gave bluish coloration after eating. But this time around, after eating, we have orange color. Orange coloration. That's to tell us that the conch HCl and the heat applied on the sucrose has been able to break the glycosidic linkage that join the glucose monomer to the fructose monomer, whereby having the glucose as a separate entity and fructose as a separate entity. And as a matter of fact, the reducing end of the glucose is now free for reaction, while that of fructose also free for reaction. That is why we have this positive test. So this confirmed to us that sucrose has been hydrolyzed into its constituent monomer, which is glucose and fructose. An application of Benedict reaction on the monomer of sucrose tests positive to Benedict reaction. That is the end of the practical series for today. Hopefully next time when we meet, we shall be taking on another topic as far as the practical series is concerned in BCS 201, General Biochemistry 1, in the Department of Biochemistry, College of Biosciences, Federal University of Agriculture, Abeokuta. Once again, my name is Oluride O. Joseph, the Chief Laboratory Scientist in the Department of Biochemistry.